Hello, this is Dr. Johnson. I'm one of the AP Stats teachers at Capel High School, and I want to welcome you to this lesson on confidence intervals for a proportion. Here is the general formula for the confidence interval. It's the statistic plus or minus the critical value times the standard deviation of the statistic. So in this lesson, we're going to talk a little bit more about the critical value and the standard deviation of the statistic. That section in blue is sometimes referred to as the margin of error. Margin of error. So, critical values. In this semester, we're going to use two critical values, the Z star and T star. They come from the calculator or a table of probabilities. They are not calculated. For example, if the sampling proportion p hat varies according to an approximately normal distribution, then the critical value Z star comes from a table of standard normal probabilities for the confidence level that we want. For the 95% confidence interval, the precise critical value for Z star is plus or minus 1.96. That's because 95% of a normal distribution is found within plus or minus 1.96 standard deviations from the mean. Here are some more Z values with their corresponding confidence level. Now I want to talk about standard error. In some texts, when the standard deviation of a statistic is estimated from the data, the result is called the standard error, and it's abbreviated SE. Now, statisticians have not agreed on a common vocabulary with regard to standard error or standard deviation, so I just have to be aware of that. It is interpreted as the typical distance between the sample statistic, p hat or x bar, and the true population parameter, mu or rho, in repeated samples. Here are some formulas. I'm going to go over the top row today. The next unit will cover the bottom row. So the standard deviation, this is what we learned in chapter 7 at the end of second semester. Standard deviation for p hat is that formula right there. And in the standard deviation, we use rho. But in this chapter, we do not know the true rho, so we're going to be using the standard error. It's the second box on the top row. And so what we've done here is we've replaced rho with p hat, and that gives us our standard error. Now the margin of error, that's the standard error times Z star. When the conditions are met, the sampling proportion p hat varies according to an approximately normal distribution with mean equal to rho and a standard error given by that equation. There are three conditions that we need to check before we perform a confidence interval for a proportion. The first is the random check. Does the data come from a random sample or a randomized experiment? If it doesn't, it's not worth very much. We're going to have to start over and get good data. We can't fix bad data with good mathematics. The second is the independent observations, or the 10% condition. When sampling without replacement, we need to check that the population is at least 10 times as large as the sample. We're calling that the 10% condition. And the third condition is the large counts condition. In this condition, the counts of success and failures in each sample or group is at least 10. And you're going to have to do the math when you check this. You're going to have to actually multiply n times p hat and show that it is greater than or equal to 10, and also multiply n times 1 minus p hat and show that it is greater than or equal to 10. And this time we're going to be using p hat, the statistic, not the parameter, because in this chapter we do not know the value of the parameter. When those conditions are met, the formula for a confidence interval for a proportion is given by that equation right there. P hat is the observed proportion of success, and n is the sample size. Z star is the critical Z for the confidence level that we are looking for. For the 95% confidence level, Z star is 1.96. Note that the standard error for the confidence interval uses the calculated p-hat, not rho, because in this unit we do not know what rho is, what the true proportion is. And also notice that the width of the confidence interval tends to decrease as the sample size increases. Here, the width of the interval is proportional to 1 over the square root of n. Now, how are we going to analyze the inference problems? We're going to use the same four-step process that we talked about before. In the first part is the identify section. Here I want you to define the parameter that you want to estimate and state the confidence level. Then you're going to check the conditions. It's not enough to just name the conditions or put a check mark in front of them. You actually have to use the facts of the problem to show that the conditions have been met. Also, I want you to identify the correct inference method by name or formula. Calculate. If the conditions are met, then I want you to calculate the confidence level and interpret the confidence level in context. So we're going to do one of these problems here. In her first grade social studies class, Jordan learned that 70% of the Earth's surface was covered in water. She wondered whether this was really true and asked her dad for help. To investigate, he tossed an inflatable globe to her 50 times, being careful to spin the globe each time. When she caught it, he recorded where her right index finger was pointing. In 50 tosses, her finger was pointing to water 33 out of those 55 times. Construct and interpret a 95% confidence interval for the proportion of the Earth's surface that is covered in water. Well, first thing we do is identify. I want to define my parameter and state the confidence level that I'm using. We want to estimate rho, the true proportion of the Earth's surface that is covered in water, with 95% confidence. Conditions, here are my conditions. We started out by naming the procedure. We will use a one sample Z interval for rho if the conditions are met. That's the name of the procedure, a one sample Z interval for rho. Random, the 50 locations are randomly selected by spinning the globe. Independent or 10% condition. This time we don't have to check the 10% condition because the locations were selected with replacement. Therefore, there's no need to check the 10% condition. We have independence. Large count, well, my p-hat is 33 out of 50, which is 0.66. So I have to take n times p-hat. That's 50 times 0.66. That gives me 33, which is greater than 10. And n times 1 minus p-hat, which is 50 times 17 out of 50, which is 17. So both are greater than 10. We've met that condition. Now, take out your calculator. I'm going to walk you through this right here. I'm going to give you the calculator syntax for the one sample Z interval for proportion. First of all, from your main menu, enter the statistics module. That's module number 2. Press INTR. That's for interval. That's F4. Press INTR or F4 for interval. Now, what type of interval? It is a Z interval. So hit F1, Z interval. And what type of Z interval? It's a one proportion Z interval. Okay. Now you're going to get a screen like this, and you're going to have to input these numbers. Our confidence level is 0.95. X is the number of successes. That's 33. N is 50. That's the number of times he spun the globe or spun the balloon. Okay. You hit execute, and it's going to print out. It's going to give you this right here. The lower boundary is 0.52869. Upper boundary is 0.7913. The p-hat was 0.66, n is 0.5 is 50. So on your answer sheet, write down that lower and upper boundary. Now we need to come up with the Z star. We need to come up with the Z star for the 95% confidence level interval. So I go back to module number 2. This is a distribution. It's a normal distribution. And I want to find the normal, the inverse normal. So I hit tail center. Area is 95. So this is going to give me the Z that has 95% of the data in its center. I'm using sigma of 1 and mu of 0, so I'm using the standard normal distribution. And that tells me that Z star is 1.96. So I'm going to write that down on my answer sheet too. Okay, so now here's my formula. Here's my formula. P hat is plus or minus Z star times my standard error. So I plug in my P hat, 0.66, plus or minus my Z star, 1.96, times, and I put in my standard error formula right there. Okay. And at this point, really what you can do is just put down the answers that your calculator gave you, 0.529 to 0.91. That's what your calculator gave it. Put parentheses around it. If you want, you're welcome to do the math and confirm that the equation that you got, the equation that you wrote down, does in fact generate the endpoints that you've there calculated. But now we have to interpret it as well. We are 95% confident that the interval from 0.529 to 0.791 captures the true proportion of the Earth's surface that is covered in water. Okay. And just as a note, this is consistent with the claim that 70% of the Earth's surface is covered in water, because 0.70 is one of the plausible values in the confidence interval. I also put up here at the very top, I put down my calculator notation for how I got my Z star equal to 1.96. And that will be a complete answer to that question right there. One more item we need to work on is choosing the sample size. Sometimes we'll give you a problem and we'll ask you, what is the minimal sample size that will generate the margin of error that we want? So the formula for a margin of error can be rearranged to solve for the sample size n, the minimum sample size needed to achieve the given margin of error. So let's say that we wanted to find, what is the sample size n that will give us a margin of error of no more than 0.2 or whatever it is. So we're going to plug in our Z star. We're going to have to give you P hat, and we'll give you the margin of error, and then you're going to solve for n. Now, Z star is the standard normal critical value for the confidence level that we want, but we don't know P at this time. We don't know what rho is. And since P hat is not known, we have to use one of two approaches. We're going to select P hat based on a pilot study or on past experience, or we're going to use P hat equal to 0.5 as a conservative guess to find an upper boundary for the sample size that will result in a given margin of error. So if we ask you to find the minimal sample size that will give us a certain margin of error, you're going to have to find Z star, and we're going to give you the margin of error. You're going to decide whether you're going to use P hat as 0.5 or P hat based on a pilot study. And then you're just going to solve that equation for n. Now, when you do so, you might get, let's see. When you do so, you might get an n that is not an integer. We always have to round up, always round n up to the next highest integer. Sample size must be in integer. And that's all I have for you today. Thank you for joining me on this lesson.